Here we go with problem 40. It says the volumes of two spheres are in a ratio of 1 to 8. The volumes are 1 to 8. So this one guy, we'll call him sphere 1. Here's sphere 2. This guy, for every 1 cubic foot it has, this guy has 8 cubic feet. This guy's 8 times bigger. So they're saying what happened back in the formulas to the radii? What's the ratio of this guy's radii radius to that guy's radius? Okay, so we know the formula for volume is 4/3 pi r cubed. And this guy, it's the same thing. It's a sphere, 4/3 pi r cubed. Now notice they both have the 4/3. So when we go in and do this, when we multiply, this guy's going to have, for the volume, every 1 cubic bit it has, this guy has 8. He's 8 times bigger. And then notice when we multiply, this has 4/3 pi, that has 4/3 pi. So that's not going to change anything. There's something we did with these radii that changed it, that made the final answer come out. The final answer came out, for every 1 he has 8. So we got to work backwards and say, okay, what happened? Well, for every 1 this guy had, this guy has 8. And notice we were cubing it. So if we come in here and we want to work backwards, if we just take the cubic root, well, the cubic root of 1 is 1. What's the cubic root of 8? 2. Notice if this radius had been 1 cubed and this radius here had been a 2 cubed, when we go to calculate the volume, he just becomes a 1. He becomes 8. He's 8 times for every 1 that guy has. So this is our answer of what's happening to our radii. The ratio of the radii is 1 to 2. So it's going to be choice D. And if you weren't sure, you could always come in here and just put in a radius of 1 and that guy's radius of 512 and see, hey, does this volume, is it only 8 times bigger? Obviously not. You knew the answer had to be smaller. It had to be a smaller numbers here for the ratio of the radii. And there it is. Choice D, 1 to 2. I know we struggle with these, but we've worked on them enough that we should be able to get this. Problem 40.